Så, kära vänner, då är klockan 12 och jag har den äran att få hälsa er hjärtligt välkomna till denna installationsföreläsning som Behzad Godrati ska hålla i ämnet drift- och underhållsteknik. Behzad kommer strax att presentera sig själv lite mera och han kommer också övergå till engelska, för föreläsningen kommer vara på engelska. Jag som är ordförande här idag är Lena Abrahamsson. Jag är prodekan vid den tekniska fakulteten vid Luleå tekniska universitet. Installationsföreläsningar, det hålls av alla våra nya professorer. Och de nya professorerna, de installerades vid den akademiska högtiden, det vill säga de fick motta sitt diplom och installerades av rektor som professor vid LTU. Det var den 10 november. I år var det 16 nya professorer och Behzad var alltså en av dem. Och det är vi väldigt glada över. Jo. Installationsföreläsningar, det är en speciell sorts föreläsning och där får vi lära oss grunderna i ett forskningsområde. Och vi får även ta del av forskningsfronten så det kan bli väldigt spännande och väldigt varierande. Jag tycker det är väldigt roliga föreläsningar att lyssna på. Den här föreläsningen tar ungefär 40-45 minuter. Och det är öppet för frågor efteråt. Titeln på Behzads presentation är att beräkna industriella systems livslängd. Och det handlar om behovet av att förändra traditionellt tänkande i underhåll för att minska kostnader och skapa hållbarhet. Och det handlar om det att vi behöver gå från förebyggande och korrigerande till förutseende när vi diskuterar underhållsarbete för maskiner. Och det kommer att handla, skulle jag tro, om maskiner som används i gruvindustrin. Men jag är säker på att det är kunskaper som kan användas i många andra branscher också. Så, Behzad, the floor is yours.
Ja, tack Lena för bra introduktion. Först jag säger bara två kort sentens på svenska. För våra svenska gäster. Jag heter Behzad och jag är glad att här idag och presentera om mitt själv och mitt jobb. Och eftersom det finns många engelsktalande folk här, därför jag tänkte bättre jag förberett mitt presentation på engelska. Jag kommer att prata på engelska, men om ni har några frågor vi kan köra på svenska om ni vill. Thank you for everyone to coming here today to listening my presentation. As Lena said, I'm going to talk today a little bit about myself, my background, the way I have come, and where I am now, right now, and what's my plan for future in this new career. I divided my presentation in 3 parts. In the first part, I will talk about myself, as I said, give you a little bit information about my background, my family, and so on, my hobbies. In the second part, I will talk about one general topic, which is remaining useful life estimation, which I will present one example, real-world example in the mining machinery. And in the third part, I will talk about future of my future plan, or what I'm going to do, or what I'm planning to do, or what I like to do. In the first part about the personal presentation. Who am I? My name is Behzad Godrati, as you see here. I'm living in the Porsche Barriet in the Porsche in the Luleå. You can have my telephone numbers and my email address, and also you can find my short web page in our division's homepage. I don't know, wait, sorry. I did one big mistake. Yes. Now, where from I'm coming? I'm coming from Is there any laser pointer in that one? No? Okay. I'm come from this city, Tabriz in Iran, which is located in the northwest of the Iran, close to Turkey and Azerbaijan. And that's why my mother language, mother tongue is Azeri and Turkey. But our national language is in Persian. For education, after high school, I moved from Tabriz to Tehran. I did my bachelor and master in Tehran University in the mining engineering side. Then after that, I moved to Luleå, Sweden to do my PhD. I did my PhD in the Division of Operation and Maintenance Engineering, which I now belong to this division. And later on, I stayed as an academic member in this university. Of course, I'm male. I'm married. My wife, Saide, she's presenting here. And she's a teacher in the Luleå schools. And I have one son, Shayan, 23 years old. He is a student at the Umeå University. And I have one daughter, 12, close to 13 years old. And she is in the Porsche-skolan. You can see all of us in this picture. This is, of course, in the hat ceremony this year. Is the latest picture we have. My wife, Saide, my son, and his roommate, and this is my daughter, Shania. About the academic qualification, now I am in the position of the professor, holding that professor position from the January 2018 this year. Before that, I was holding the associate professor position from 2011. Before that, I went to Toronto. I did my postdoc in the Toronto University for 2 years after my PhD, which I got in 2005. And I have a master's degree from, as I said, the University of Tehran Faculty of Engineering, which I got in 1993. Employment background. Now, as I said, I'm in the position of the professor in the Division of Operation and Maintenance Engineering. Before that, from 2011 to 2018, beginning of 2018, I was associate professor in the same division. And 2008, I left to University of Toronto for 2 years to do my postdoc. And I did my PhD, I finished my PhD in 2005, which I have entered to that PhD program in 2001. And during my PhD, I was also working as a lecturer, one different course. One of the courses, still it's alive, is going on, is Applied Operation Research. Before coming to Luleå to do my PhD, when I graduated from the university in Iran, I joined one university, Sand University of Technology, as an academic member from 1993 to 2000. And during that period, I did some consulting work, which you can see here in different companies. The Kashiran is one of the, I think, the first and one of the biggest tile manufacturing company in Iran. I was consulting engineer for that company. And I was also working in as a project manager in one consulting company while I was doing my master. And the result of my work in that company and my master thesis, which is this one, which was the design of the mine shaft, one of the biggest mine shaft, 4-meter diameter and 400-meter depth. Actually, I did all the work 90% by myself. But some part which was not in my specialist, I take help of some friends. Of course, this is the old one. Now everything is the digital, but that time everything was on the paper. That's why we draw even the map on the paper. And also, during my, working time in the Sand University, I was the VED and the managing director of one satellite company of the university, which was supporting the university from the personal side. My hobbies is listening to music with a high volume, and it's always conflict between me and my wife. She always says, lower the tone, but I like to listen with a high volume. Swimming is one of my hobby. After doing operation in my backbone, the doctor was suggested me the best way to treatment is swimming. That's why I also like swimming. Reading magazine, reading news, reading books, articles. And one of the best and the biggest and the important my hobbies is a handwork. Testing, servicing, repairing, any, let's say, industrial and not industrial tools. When I'm telling not industrial, in the home, for example, house repair, car repair, electrical, even some tools, one machine in our home, when it fails in the first step, I try to fix it by myself. If I can't, then I take to the repairman or shopman. It doesn't matter which devices, even the TV, even the computer, even the laptop, whatever else. And this is my, I think, the important hobbies. Here, you can see some picture of what I have done or my hobbies. The first picture here, it is the fixing and constructing of my Altan this year, this summer, which I did it. It was before that, it was the end after fixing it. And as you see here, I'm always curious to find the failure of the machine. Here I'm doing some repair on the service of my own car. And whenever we go for field visit, the first choice in any opportunity, I go to the workshop and see what the people are doing in the workshop, which is the mining area. And also, as you see, fixing the home. Here I'm changing wallpaper and building one new room in my house. From the personal characteristics, I'm a social and easygoing man, easygoing person. It is not only I'm claiming, all friends also, they say. I'm always thinking positively, optimist, because by being pessimist, actually, it suffers. We are suffering with being pessimist, but optimist, it gives you some positive energy to go ahead, go further when you are optimist. And I enjoy helping people and make them happy. Even if you can ask my friends, of course, hopefully, they will confirm which I am helpful man. I'm helping them. I don't like lying and hate it. And I believe in being simple and transparency. As they say, walk the talk. Actually, I'm trying. And I'm doing this one. I'm walking the talk. And I, of course, enjoy of my working environment. Why? Because always we are dealing with the new and the young generation people. That's why in this work, I never ever feel I'm getting old. Because always your customers are young and the fresh people, which is the students. That's why I enjoy my work. If I want to conclude by myself, in summary, I'm a simple man, easygoing man, handyman, and helping people. Sometimes I put a lot of time and let's say cost in the form of the time to helping the people, and my wife also reminds me always put some of that time which we are putting to another people to our home to us. It was about myself a little bit, to give you some information. Now I'm going to the second part, going to present one topic, but in the general format. Don't expect me I go to in the detail. This is just general to give you some view, because I thought maybe some other people also will be in this presentation which doesn't have that much knowledge about this topic. That's why I have asked to present the topic in a very general format. I'll talk about the remaining useful life. What's the remaining useful life? I'll give you one example from myself, from the human science point of view, to clarify, to open this concept. This is me, this picture. Hopefully you can, it is an old picture, I just scanned it. When I was 18 years old. For this talk, I have some assumption here, you can see. I assumed the qualified age to start the work is 25 years old. Of course, you have studied, you have done your, let's say, university, you have done some courses, now you are expert or you know, you have some knowledge, and you can start to work. That's why starting age is 25 years old, and the retirement age is 67, and the average life is 82 years, I have considered. When I'm 18 years old, and I'm going to retire in 67 years old, then my remaining useful life will be 42, because I will start to work when I'm 25 years old. I'm not starting from 18 years old. But my remaining life is from now, from 18 years until I pass away. This is 82, then it comes 64 years. See, 64 years is the remaining life, but 42 years is remaining useful life. When I'm 25 years old, or I was 25 years old, my remaining useful life is the same as the previous one, because I started to work from the 25 years old age. But my remaining life has decreased by 7 years. Now I have 57 years remaining life. When it comes to now, which I'm around 50, 52, my remaining useful life is decreasing to 17, because after 67, I'm not that much useful to the society. I will get retired. But my remaining life still is 32. When I got retired, my remaining useful life becomes 0. But still, I have some life. This is the scrap value. When one of your machine is getting old and you are not able to use it, or it's getting very frequently failure, you can scrap it, but you will get some money for your machine when you are scrapping it. That's the remaining life, but the useful life is 0. Okay, with this introduction, if I go to one real industrial case, which we did as a case study, it was about the mining loader. Mining loader, when it's brand new, coming out from the factory, it has not been used. The time is 0, T0. Then I'm using this machine for some years. Now I am here in the present time, which is the T1, until the system gets old and I have to throw it out or scrap it. T2. The remaining useful life for me, or the meaning of remaining useful life at the present, is how long this machine is going to survive until getting scrap. That's why remaining useful life is this T2 minus T1. I don't look at my back where I have started. Now I estimate my remaining useful life from this time, this second. But sometimes the remaining useful life is less. Why? Because we have some extra factors, external parameters, like the weather. Machine is working under the harsh environment, in the cold, or in the very hot, or very dusty environment. That's why this external factor causes your life of the system become shorter and shorter. That's why your machine will get scrapped very soon. Here, remaining useful life is the same definition. T prime 2 minus T prime 1. But this new T or T prime is less than the previous T, because here you have less life because of the effect of this external factor. If everything was under control, okay, let's say 22 degree temperature, not that much raining, not that much humidity, okay, your machine could survive more. But in the mining, let's say, environment, when there's a lot of the dust, humidity, pressure, and so, something like that, then your life of the machine will decrease. This is, again, I have to consider this environmental factor in the estimating a remaining useful life. Remaining useful life, now it is different than previous case, which we have no any external factor. Remaining useful life is a random variable. It says how long my system is going to survive from this time, from now. It is a function of time and some another factor, as an external factor, as I said. As you see here, this is one ball bearing. When it's working in the normal condition, its life is going to deteriorate, but with the normal situation. Sorry. Here, this is a remaining useful life, if I am standing here, is this much. But when I'm putting pressure or high load on the ball bearing, or not maintaining, not lubricating it, this ball bearing will deteriorate very soon, very fast. It comes this curve. That's why my remaining useful life will get shortened. But if I lubricate it, if I take care of the ball bearing and service it on time, I can prolong its life this much. It means my remaining useful life will increase. The middle one is a normal. The left one, when there's a harsh condition. The right one is when I'm taking care, I'm doing service, I'm lubricating, taking care of the ball bearing. That's why I'm prolonging the remaining useful life. For defining the remaining useful life, I need to have some thresholds. Well, which thresholds are this? The service threshold, this is the maintenance threshold, and the safety threshold. As long as I'm upper than this line, service threshold, my system is safe, it can work. When I'm dropping here in between, it means I have got some sign which failure is close. I have to take action, either to service it, maintain it, or do some improvement work. If I don't do that, I will reach to this level, which my machine will fail, and this is the catastrophe. Then I can define 3 levels of the survival of the machine. As long as I'm upper than this line, which everything is under control, my light is green. When I reach to the maintenance threshold, light is yellow, giving me some warning. I have to take, as I said, action. When I reach to this level, safety level, I am not able to use this machine anymore because I have got failure or it is dangerous to use it. Now, remaining useful life, how we can estimate remaining useful life, is commonly, in general, is estimated by the reliability function. What's the reliability? Reliability is a probability that this machine or system can survive, can work, can do its defined work under the given condition for a specific point of time. As long as I'm here, my system has worked this long way, I'm happy here, but I want to estimate when my system is going to fail, when I'm getting to have problem here. This is now this time can be here, or can be here. That's very random. But it gets affected by different factor. If I calculate this remaining useful life by reliability, I know the reliability is calculated by the hazard rate, failure rate, is a measure of the reliability. Failure rate is the number of failure in the unit time. That's why if I have bad condition, then my machine will get failed very frequently. If I use the car, let's say the BMW here in Sweden, may it survive 20 years, but if I take this BMW and use in Saudi Arabia, maybe it works just 15 years because harsh condition, different situation. These conditions, this environmental factor, which we call them covariate, will affect your failure rate, will affect your hazard rate, will make your failure rate very high, which your system, as I said, will get failure very frequently, or will decrease your failure rate. Your machine can survive long time. The BMW can get failure in each 15 years in Sweden instead of 10 years in Saudi Arabia, for example. I want to give you some example about how does this covariate affects your remaining useful life. This example is from the mining industry. You know, mining is a really big industry, huge scale, and we have a large scale machinery, complicated machinery which is used in mining. And this is some example for loading, for hauling, for loading, for drilling, and so on. As I said, this is a harsh environment. We have a lot of factors which affects the function and the reliability of the machine. The example, the case study which we have done, I'm going to talk, is about the LHD, loud hull dump machine, which is the big loader which is used in the underground mine. One component of this LHD is a hydraulic jack. My case study was on the hydraulic jack of this machine. I want to see how environmental factor will affect the failure of this hydraulic jack, and how can I estimate the remaining useful life of this hydraulic jack. When I was in the mine and studied, I talked to some experts in the mining. We found these 5 factors are influencing factor, are important factor which affect my failure rate. The operator skill, maintenance crew skill, hydraulic oil quality, is it the manufacturer recommended or not, hydraulic system temperature, and environmental factor. By doing survival analysis, I found these 3 out of that 5 has significant effect on the failure rate of the hydraulic jack. Of course, this was the estimation. I don't want to talk about that. These 3 factors will affect your failure rate of the hydraulic jack with this equation. This is the baseline failure rate hazard rate, which is a function of only of time, and this external factor, dust, operator skill, and the temperature, which affects this hazard rate with this multiplication. These 3 factors can be in the combination in the 8 format. Either all of them are positive. What does it mean by positive? They are in the good condition. My operator is fully skilled. I don't have any dust in the environment, working environment, and temperature is in the normal temperature, not high and not less. That's why I codified this temperature or this state with the code of 1. When all covariates are in the bad condition, in the negative effect, I have codified with the -1. The combination of these 3 factors, as I said, can be in the one of these 8 situations. If I calculate the hazard rate, I see hazard rate in the worst case when the 3 covariates have negative value effect, on the hazard rate is increasing exponentially. But when it's in the good condition, all are positive, it's not increasing that much, it's almost constant. But in the case in between these 2, you can see how does it affect, how does it works. And this is the reliability. As you see, reliability is decreasing very smoothly, very, very slowly when I have a good condition, when the covariates, all covariates has not negative, positive effect on my failure rate. And here, when all covariates are negative, you see failure rate, how it sharply decreases. And it shows the reliability, conditional reliability. It means my system has already worked for 2,000 hours. I want to know how much reliable is it for next 2,000 hours, which is the 4,000. It tells me in the good condition, I have 98% reliability in next 2,000 hours. My system has worked already for 2,000 hours. I'm now 2,000. Next 2,000 hours, my reliability will be 98%. But in this bad condition situation, when all covariates are negative, it's almost zero. And also, when the age was increasing, now I have worked for 2,000, for next 4,000, 6,000 hours. What's my reliability? It's 82% just. See, as the age of the system is increasing, and also covariates getting bad and bad, my reliability is decreasing. This is the reliability function, how does it looks. In the good condition, see how does it decreases, and the bad condition, very sharply, very short. And this is the remaining useful life estimation based on that conditional reliability. What does it mean by conditional reliability? Reliability which gets affected from the covariates. As you see here, in the age of 1,000, system has already worked for 1,000. Remaining useful life in the case of all covariates is positive, is 11,000 hours. But when it comes, the system has two negative covariates. It comes to 1,000 just 900. When my system is 3,000 hour age, remaining useful life is 8,000. In the bad condition, when I have two negative covariates, it is just 4,000. As you see, as long as my age of the system is increasing from up to down, and the covariates condition is getting worse and worse, my reliability, sorry, my remaining useful life is decreasing. It shows the context-driven remaining useful life estimation. Remaining useful life estimation is based on the real conditional real situation. Okay, it was my second part and the third part of my presentation about the future, direction of future, in future, what I am planning to do. This is just overall picture based on my background, based on my knowledge which I have got so far from the mining side, from the reliability and the machine side. The research I have done in the, about the mining process, about the remaining useful life, about the product support and so on. I'm trying to get help of these enablers, help of new technology, new techniques, to reach to the application of Industry 4 in the mining, which we call it, I call it Mining 4. I have, as I said, the knowledge and experience and little bit background about the mining process. I know how does mining work. I know the process. I know the machinery. I know the process of the mining and so on. And this helps me to understand the situation or condition very perfectly or nice. And I have experience about the production assurance. What does it mean, production assurance? I want to see in this research how much my system, my machine is capable to deliver, to fulfill the demands. Of course, by considering the reliability of this machine. If I know the customer needs from the quantity, quality, and the cost point of view, and if I know the time limit, then I can make myself ready, my machinery, my system ready, and process ready to deliver the demands on time or assure my production. Of course, this production assurance is a function of reliability. Reliability affects your production assurance because your system should work. The reliability of machinery, I'm looking to production assurance from the machinery point of view. When my machine is reliable, when my machine is working long time, when my machine is available for a long time, then I'm able to use it and to produce the material, produce the product. One of the parameters which limits me in the availability is a product support, the spare parts. It's how long I have to wait to get the spare parts. And this is the logistic. I know about the logistic. I have done some research. That's why I have knowledge about this also. It will help me to go further. I have calculated, I have estimated the spare parts in my PhD period when I was estimating the spare parts by considering the criticality of that spare parts, considering the system availability, considering the maintenance scheduling, maintenance planning, and also inventory problem, management of the inventory. How many spare parts I have to keep in my inventory. Whenever I need, I should not face with any shortage. But I cannot keep too much spare parts in the inventory because it's the blocking of the money. Okay, by knowing all these things, I'm going to talk about estimate the remaining useful life. And based on remaining useful life, I'm going to see how can I use the new technology to estimate the remaining useful life in the correct and the very accurate way. We are talking about the remaining useful life in our life, but everybody use, but they don't maybe know the name of the concept they are using. When you are going to buy, let's say, one TV, you are asking how many years guarantee have this TV. What does it mean? It means how much you can trust on your TV which will work for you. But the guy says 3 years guarantee. What does it mean? It means the manufacturer or the seller, they are sure the TV 99% will work for 3 years. Then the reliability of this system, this TV is 99% just for 3 years. When we are talking about the reliability, we have to talk about the time also. 99% reliability is not forever. It's just for 3 years. After 3 years, it will start to fail. That's why now I want to see how much I can trust on my system, what's the remaining useful life of my system, what's the reliability of my system. As I said, we use in our daily life, maybe without knowing it. We check the engine oil of our car. For what? To see what's the quality of the oil, how long my car can run. Based on the quality of the engine oil, I can predict, okay, oil is still clean. I can drive 1,000 kilometers more. But if it's dirty, no, better I change it in 500 kilometers. This quality of the oil, let's say the sample indicator, show me how much I can trust on my system and how much I can use it. That's why it shows me the remaining useful life of the machine. Why I'm doing this one? To get rid of this situation, failure. This is a ball bearing, but these balls are not working. That's why my ball bearing is not working. I want to avoid the failure of machine by calculating the remaining useful life. When I know my machine is going to fail next month, then I can take some action after 2 weeks to fix it, not get to the failure. In the new world, to analyze this condition of the machine, a lot of sensor they have put in the machines. New machines have a lot of sensor. We are getting a lot of data every second, every millisecond maybe, with a different format, in the different velocity, with different volume. And it gives me to face with the big data. I don't know, big data is not the size of the data, it's the volume of the data, is the veracity of the data, is the validity of data, it's a different concept has the big data. And I'm facing with this concept these days with the new machinery. And I don't know how to do this with this much of data. What I'm planning to do, I would like to transfer this data to the information and get some knowledge from this data to be able to make decisions about my machine. Nowadays, every industry talks about the automation autonomous. In the autonomous operation, it means machines are working by itself. That's why in a fleet, in a one, let's say the environment, different machines are working. They are instrumented. They are instrumented with the sensors, getting the measuring different parameters. But they should interconnected. Machine should talk to machine. In the autonomous, let's say mining, when one truck coming from one tunnel, another from another tunnel, there is no operator. They should interconnect. They should communicate to each other, stops, then recognize which one has priority to go. Priority is with the truck which carrying the ore. Okay, this truck will go, the another truck which is empty will go later on. This is interconnected. And the truck should be intelligent, as I said. When they stop, they should make decision, which one should go first. That's why we use the industrial internet or Internet of Things, which all machines are interconnected or connected to each other in one environment which are working, different machine. As we see here in the mining, let's say the hauling system with the drilling system, with the loading system, and so on. All should be connected and be communicated. If it is done, then we reach to the autonomous operation. Autonomous operation means operation without operator, not automation. Automation is different than autonomous. In automation, we do with one machine, and when we control the operator can sit somewhere else and automatically control the machine. Or one machine can work single, individually, autonomous. But when autonomous operation we are talking, all machines are working together in one environment. That's why what is important here is a communication. It's the backbone of the automation, we call it communication. The machines should communicate to each other to know which one should do what and when and where. I have one short movie here, wants to show you.
First truck in the world that could drive all by itself in these difficult conditions. It uses laser sensors to see. Time to drive on. It's still a concept truck, but we are already testing it in real operation. This will truly change the mining industry and the whole society. It will make it more productive, more sustainable, and safer. And it's just the beginning. All industries will be influenced in the future.
Time, okay. Then another, to go to the mining for, as I said, Industry 4, then I want to show another movie. It's at 2 minutes if I have time.
Yes, very shortly.
Yeah, because it's nice also to see that one also.
I would like to have the opportunity so they can ask you some questions as well afterwards.
Then I can stop here. Then I can stop it here. Just for last slide, I have borrowed this slide from Uday. This is the improved version of this, whatever I have shown you before. This is the improved version, to go further to the, let's say, the mining for industry. For in the mining, we need to have domain knowledge, which is about the mining machinery, mining process, and so on here. And then I have to use some supportive technology like CMMS, computerized maintenance management system, or other systems. And based on this this chart, I have to use the optimization technique, which is the application of the RAMs and lifecycle costing. And then I end up with the transformative technology, which is like e-maintenance, like context-driven remaining useful life. And based on that, I will end up with the disruptive technology, which is the mining for. I have to break something. I have to break some rules and come up with a new idea, with the new findings. And all these things is planning to be in the digital format, digitalization, which helped me to get to my planned goal in future. It was yesterday I was looking some internet, I saw even in the Rio Tinto, they are thinking exactly or be like us, or we are thinking like them. They are also see the mine of the future. They have think the big data analytics and the automation and the smart people and smart operation and so on. Thank you.
Thank you very much for a very interesting lecture. Now I would like to open for questions. So who wants to ask the first question? I will come with the microphone to you, so just raise your hand.
Uday, of course.
Uday, of course.
On your table, which you were showing the covariates, you said the life will be reducing with this introduction of covariates. But there was a state 4.
Yeah, yes. In the state 4, Uday, we have just one negative, two. Let's say in the state 4, we have two negative effect, one positive. Then the rest, we have just one negative.
It's going down and suddenly increasing.
Yeah.
That's my.
Yeah, I will listen.
Go down. You heard it. Down.
See.
Next one. Go to the next one. Next. Go further down. Yeah, this one.
See, here, because in the 4, as I said, see in the 4, we have two negative effect and one positive. But in the 5, we have two positive, one negative. That's why it comes and then goes up.
Thank you, Behzad, for your presentation. You talk a lot about remaining useful life. My question is very general question.
Dangerous?
No, general question.
Ah, general.
General question.
I thought you said dangerous.
And you talk about your career from 18 years till the end place, which you mentioned. Which way you can, what your thought about prolonging your life?
My life?
Yes. Which way you can prolong your life?
This is the maintenance, actually. Which kind of maintenance I'm going to do?
Yes.
See, I have done some repair work by myself. As I said, I got backbone problem, disc broke. I did operation. If I was not doing that, then definitely I could live them. For future, improving my lifestyle. Lifestyle comes from, let's say, the social activity, from even scientific activity, from different parameters there. I mean, but, yeah, I got it. Being optimist. Always think positively. You will survive more.
Thank you. That was a very nice ending of the lecture. But perhaps there is someone more question?
In this diagram here, when you try to estimate the hazard function before this, you are splitting in categories. Do I understand that you are trying to formulate this as a factorial design problem, analysis of variance, and looking at the most relevant parameters?
Yeah, I mean, the survival analysis is similar to the factorial design. I mean, but of course, in this example, I have, just for simplicity, I have codified it, but we can put the exact value of the covariate. For example, if it's the dust, we can measure the dust, the number of the particles in the centimeter, cubic centimeter, something like that. We can put exactly the value of this measured parameters in this calculation. But here, just for simplicity, I have codified it +1, -1. That's why.
Exactly, that was what I was going. Why only 2 levels? So you already explained that. And the next thing is, how do you then, if this is similar to factorial design, how do you assure that the experiments are independent? And do you have problems with the
IID?
residuals?
In the data collection, we first test our data for that IID assumption, then we use it. Yep. Thank you.
So, any more questions? Then I would like to end up with this optimistic and positive perspective, and would like to say that Luleå University of Technology is very pleased to have you as a professor, and we look forward to more and interesting and in the front line research.
Thank you.
So this is a small gift as thank you for the lecture and welcome.
Thank you, Lena. Thank you. Thank you.